Okay, so as we get into this first example where sigma is known, I want to talk about p-values first. And p-values have everything to do with the amount in a tail. So we're going to calculate a z-score and then figure out how much is in each tail. So as we do that, some of the different general rules of thumb is if you have a p-value that's less than 0.01, there's overwhelming evidence that the alternate is true, which basically means significant difference, significantly less or significantly more. If it's between 0.01 and 0.05, it's strong evidence. So that's why I said before that 0.05 or less is strong or significant evidence. Between 0.05 and 0.1 is a little bit weaker, and then greater than 0.1 you say there's just not enough data to tell me that there's a difference. And again, a difference would be similar to an alternate hypothesis. So let me show you, I just graphically showed it up on the whiteboard here. Your 0.1, you can see, is represented as these two lines. And as you can see, what that means is in these two values, or let's just look at the one side here, from here over, when you're doing a right tail test, if it's 0.1, that's about where it is. Now, if the p-value is 0.5, that means the amount in this tail is 5% as opposed to the 10% that we had before. That's why it's farther away. The farther away from the mean, the more significantly different you are. So when you get to 0.01, you're really far from the mean. There's not much in that tail, and that's why you can say there's strong evidence, overwhelming evidence, that you're significantly different than the mean. So when you look at p-values, which Excel gives you the p-value, it makes it really easy to make the decision right away. If the p-value is less than 0.05, guess what? Significant or strong evidence to say that there's a significant difference. Okay? So when you look at these graphically, you can see that if your significance level is 0.1 that you're looking at, then the p-value, if it's less than 0.1, you're saying that it's somewhat significant in that case. And if this was like 0.01, it would be way out here somewhere on my bell curve. Over here, you can see that if I said my significance level is 0.04, kind of what that means is that's kind of where what I consider my point of where I would say significant difference or not. And if I have a p-value of 0.011, then yeah, that's extremely small and pretty far away from the mean. You'll also see that the larger the z-score, the smaller the p-value. So that, again, a larger z-score is farther away from the mean. A smaller p-value is smaller away from the mean. So when we're doing a test looking at this, we can do it with p-values, and we can also do it with what's called a critical value. And we get the critical value based on what our significance level is. And we'll get into that here in a second. And then we compare that to a calculated value. And it's pretty easy to do once you understand the concept of it. So if we set up and said our calculated or critical value is negative 1.28, anything outside there, anything, let's see here, anything in this area would be significantly different, which means that it's less than negative 1.28. So a negative 1.6, a negative 2.5 would be in this region, and that would be significantly different than the mean, which is again why you support or do not support the null in this case. And so on down there. Okay. There are some steps. I want you to look at these steps in terms of your ebook, and then there are great examples in MindTap that show you how to do this. So, it's not my intent for these videos to be about showing you the step-by-step. That's already done for you. Let's just figure out what this means and use one example to do that. And so if I get to my example here, I've got response times, which I think are kind of important. You're going to want to make sure if you're publicizing that your response times are 12 minutes or less, that becomes extremely important to make sure that you are that. And you don't want to be greater than 12. Now think about what 12 minutes or less represents. So let's take a look at that up on the board up here. If I say 12 minutes or less, what I'm saying is 12 is here. Now, what I really care about is, am I greater than 12 minutes, which is represented as that tail. 12 minutes or less then is represented by this area here, which is the same as saying less than or equal to, and this area is greater than. Now, which one represents the alternate? Is always the tail, and so that would be H sub A, and then this area here is your null, which is H sub 0. So what is greater than 12? Well, if you did a sample, again, a sample of only 40, and you're at 12.1, is that significantly different? Or significantly more? What about 13.25? Is that significantly more than the 12 or less? That's what we want to determine. And in this case, because of previous data, we know that the population standard deviation, maybe based on last year or maybe based on 5 years of data, is 3.2 minutes. So with that in mind, I've written that down on the board, and we can kind of go through this as an example. So what we want to do is see if it's either greater than 12, which it would mean that we're not doing what we said we were doing, or is it actually 12 or less? And that's what we're really looking for here. We specify a significance level of 0.05. Let me show you what that means up on the board. That means that tail represents 0.05. So if you know that, can you come up with a z-score that goes along with that? Well, if you think about that, that means that this area is 0.45, this side is 0.50, that means from here over is 95%, and in there is 0.05. So at this point is 1.645, just as a z-score. That's one thing we know is for 0.05 or for 95%, it's 1.645. Now let's calculate what our z-score should be and compare that calculated value to the critical value, and then also come up with a p-value and compare it to that. So to come up with that calculation, it's actually very easy. You just take x bar minus mu over that thing called standard error, and that represents a calculated t. Now this is a critical t, so I can put that over here, and then when I do the math here, I get 2.47. That 2.47 then is, let's say it's right here. That represents my calculated value. And I don't know the p-value for that yet. We can find that. We can either use Excel to do that, or we can look it up in our table. We can actually look up the z-score of 2.47 and find it, which we'll do here. But just by looking at this, does that value look like it's significantly more than what we would consider 12 or less? And the answer is yes. So we already know the answer just by looking at this. That is greater than this, therefore significantly greater than 12 or less. So taking a look here, if we were to take that 2.47, the cumulative probability at that point is 0.9932. See if you can find that in your table, which means that tail is 0.0068. Is that a small value? Is that less than 0.05? If it is, then what you're saying is you reject the null and you support the alternate, which is the tail, and what you're saying is we are far enough away from the mean to say significantly different. So let's take a look then at the whiteboard again and see where that 0.0068 is. That is actually this area right here, which is part of that 0.05. So it's less than 0.05, so you know significantly more. The calculated value is greater than the critical value. That also tells you it's significantly more. So you have a p-value approach, and you have a critical approach to finding significant more in this case. So is there sufficient evidence to infer that the Metro is not meeting the response time? I think so. I think there is definitely sufficient evidence in this case. And when you look at it, again, you've got the p-value compared to the significance level, and the 1.645, which corresponds to the significance level, and then the calculated being 2.47. Now, where did significance level come from? It's kind of just a known standard that it's 0.05. And so when in doubt, use 0.05, and that kind of goes back to that one slide that I showed you that showed 0.01 and 0.05, and that means there's strong evidence to support the alternate. That's kind of what it represents. So we mostly will use 0.05 in here. Just make sure you know what the book is looking for when you're calculating those values. But that's how you come up with a calculated value with sigma being known. And then finally, let's take a look at what Excel can do for you. And with Excel, you're going to have to come up with some different values here. And you can come up with standard error just by doing calculation. You can then use what's called norm.s.dist. And what that does is it will create, and you can see it takes C8 here, whatever the test statistic is, and gives you a tail for that. So at 2.47, what is the known p-value for that? That norm.s.dist gives you that value. As you can see here are your values here. You see 2.47 corresponds to 0.9933, which then gives you a p-value of 0.0067 for one tail. And if you did a two-tail test, then it would represent 0.0134. Again, so looking at the critical approach, very similar to that, and you go through, and again, we would reject either based on the critical approach or the p-value approach in this case.